Given that negative 1 plus 2i is a factor of x cubed plus x squared plus 3x minus 5, we want to solve x cubed plus x squared plus 3x minus 5 equals 0. Well, the first thing to note, because we know that any complex roots occur as conjugate pairs, is that negative 1 minus 2i is also a factor. And that's really important. And that means that we can get a quadratic factor of this by saying, well, x minus negative 1 plus 2i and x minus negative 1 take 2i must give us a quadratic factor. So if we expand that out, what do we get? We get x squared take away negative 1 plus 2ix, take away negative 1 take 2i x, plus negative 1 plus 2i, negative 1 take 2i. So that's x squared. Now what you should be able to see here is that the complex parts are going to cancel, and minus minus is a plus, so I'm going to get plus 2x out of there. And then over here we've got a difference of perfect squares, so we're going to get 1 and minus 4i squared. So that's going to be x squared plus 2x plus 5. So our x cubed plus x squared plus 3x minus 5 is going to be x squared plus 2x plus 5 times some linear factor. Well, to get x cubed here, this needs to be x. To get minus 5 here, it needs to be negative 1. So what we have is x minus 1, x squared plus 2x plus 5 is equal to 0, which gives us x is equal to 1. And then we've got negative 1 plus 2i and negative 1 take 2i. And those are our three roots.